In this video, we're going to look at solving problems, worded problems, using normal distribution. So the very first thing you're going to need to do is to interpret what the question is saying. You'll need to identify the mean, the standard deviation, and the area of the distribution that's under investigation. And then you'll need to decide what it is that we're being asked to calculate. And a quick diagram, something as simple as this, always helps to clarify things. So let's have a go at a couple of problems. This is a classic problem. A company produces jars of jam labelled as 250 grams of jam, and it does an analysis of the actual weights of the jars and finds that the weights are normally distributed with a mean of 251 grams and a standard deviation of 0.4 grams. What is the minimum content in grams of 95% of all jars produced? What is the minimum content? Minimum content. Okay, so our quick graph here that we've got here has our weight here. And what we want to know is the minimum weight. What is the minimum weight in grams? So the minimum weight of 95% of all of the jars means that it's going to be the smallest weight of 95% of the jars. So it's going to be right down the bottom end here. This value here will be the smallest weight. And on the right hand side of that, we're going to have 95% of our jars, or 0.95. That made it easier to understand how we're going to work this thing out, isn't it? So what we're looking for is we're looking for this x value here. And to look for an x value, we're going to use inverse normal on our calculator. So our calculator only works from the left-hand side, so our area is going to be the 0.5 that goes here, 0.05 I should say. So when we use our inverse normal calculation, we use the area as 0.05. When we do that on our calculator, we get x is equal to 250.342 grams. One of the other sorts of questions you'll get asked is to find the mean or the standard deviation or both for a normal distribution. And so they'll give you some information about probabilities, and what you need to do is you need to use the standardized score formula. Remember I told you that you needed to know this formula? Well, you need to know this formula. So if you haven't got it, put it in your bound book. All right, so what we do is we find the standardized score for that particular probability. We use inverse normal to find the z-score, and then we substitute the z-score into our formula to find the mean or the variance or both. Let me show you how it works. So this is the sort of question that you get. If x is distributed normally with a mean of 28, and the probability that x is less than 31 is 0.64. So this is common. You'll get a probability. Then it says, of course, find the standard deviation, theta, correct to 3 decimal places. So the first thing that I would do is I would draw myself a little graph. There it is there. That's the graph that I would draw. And that helps me to see what's going on. So our proportion or our area is 0.64, so less than 31 is 0.64, which puts us over this side here. So what we're going to do is we are going to take this area here and find the corresponding z-score for this. Okay, so the corresponding z-score. So we set it up. We set it up to find our z. Okay, so put that over there. All right, so we're going to use this z formula here, and to find z we use on our CAS calculator, what we're finding is the probability that this standard score is 0.64, using our mean of 0 and our standard deviation of 1 for our standard score. So we always use those values when we're finding our standard score. Always the mean is 0 and our standard deviation is 1. So on your CAS calculator, you won't put in a Z, you will just put in that the area is equal to 0.64, the mean is 0 and the standard deviation is 1. And then when you press in go, OK, it will give you this answer, 0.358, with a whole heap of decimal places, and you'll need to remember that that is your Z score. So then your next step is to substitute that Z score into your formula that we've got up here. So there's our Z formula there, and now we're going to substitute it in. So our Z score, use your calculator to copy and paste this formula, that value there, into your formula and get it to solve. Okay, so do not round at this stage. I know the question says 3 decimal places, but if you round here to 3 decimal places and you use your rounded answer, you'll get it wrong. So just take all the decimal places, it's easy to copy and paste, and put it into this formula, solve it for theta, and you'll get theta is equal to 8.369. Try this one. Find the mean. Press pause, and then when you're done, press play and see if you get the same answer as me. Okay, I hope you drew a little picture and that you recognised that the 16 was in fact your variance, and so your standard deviation was in fact 4. You needed to use your Z formula, and hopefully you ended up with a mean of 89.34. This example, our second last example, is another classic version of a question. They talk about manufacturing and things being outside the acceptable range for a particular measurement. So this is a kind of engineering production kind of question. So a manufacturer making bottle lids has an acceptable height range of 1.9 centimetres to 2.08 centimetres for the lids. It's observed that 5% of the lids are too tall and 5% of the lids are too short. Assuming that the lids are normally distributed, find the mean and the standard deviation for the distribution. I want you to have a go at this. My suggestion is draw a picture first. Okay, there's a little picture first. Did you get the mean was a 2.01? Because it's halfway between these two values, 5% below, 5% above. These are the too tall lids, and these are the lids that are too small. And the mean is exactly halfway between these two values. And then from there, once you've got the mean, all you need to do is either choose this end or choose this end and find the appropriate Z value, and then substitute into the formula, and whichever way you go, you will get a standard deviation of 0.0456. Now the other thing that they will do with this question here is not have it symmetric here and here. Will not have it symmetric here and here. Okay, and then to solve that, you won't be able to find the mean like I've found it here. But what you will do is you will just do bottom end to find one Z value, top end to find the other Z value, substitute it into the two equations, and what you will end up with is in this position here, you'll have the standard deviation. This position, the standard deviation, you'll have your X value, you'll have your mean as a symbol, and your standard deviation as a symbol, same here and here, and then you can put these two together and solve them as simultaneous equations. Our final question comes from an exam paper. So it's 2019 exam 2, and this is question 4, the last part of question 4 on the paper. Question 4, just in case you wanted to know, and it's actually this part here that I'm interested in you having a go at. This top bit here is really simple. You've got the mean and the standard deviation here, but this interpretation question is one that caught quite a few kids out. So have a go at doing it, and then I'll show you how I solved it using my CAS in a slightly different way. Away you go. So I hope you drew a picture. And then what I did, you'll notice that this is at the bottom part. So I used my normal CDF and the solve function on my CAS to solve the normal PDF from -infinity to x with a mean of 14.1, a standard deviation of 2.1, and I made that normal CDF equal to 0.05. Asked it to solve for x. This one might be handy to put in your bound book.